So we've looked at how we can find the derivative using the power rule, the product rule, and the quotient rule. But what happens when we have something that doesn't really fit into those rules? So here we have f of x is equal to the square root of x squared plus 1. Now, I can't use the power rule here, right? If I try to rewrite this, let's say it's x squared plus 1 to the 1/2. The power rule here won't work because I have another function that's inside. So usually if we had the square root of x, we could use the power rule, right? X to the 1/2, and we could find the derivative using the power rule. However, in our new function that we have, there's something else going on inside. So the way that we can kind of think about this is as a composition of functions. So really there's some type of function. So we're going to call the y like f of u, and this is the square root, right? So the square root of u. So it's a square root of something, and then the something that's inside is your other function. So let's call that g of x, and that's x squared plus 1. So what we really have is a composition, f of g of x, and that can also be written as f of g of x. So when we're dealing with compositions of functions, where there's a function inside another function, we can't use any of the derivative rules that we already know. And so there's another type that we're going to use, and that is called a chain rule. Now the chain rule, there's two ways you can kind of go about it. The first way, written here, is the one that I will most likely be using all the time. You can decide to use either of the two, whichever you're more comfortable with. Basically what we're doing is we're taking the derivative of a composite function. So you have an outer function and you have an inner function. When you take the derivative of that, you're going to have the derivative of the outer function evaluated at the inner function times the derivative of the inner function. The second way you could think about this is with Leibniz's notation. So what this is taking the function and kind of redefining it a little bit and saying that y is equal to f of u, and then saying u, which is our inner function, is equal to g of x. And you can kind of think of it this way. dy over dx equals dy over du times du over dx. dy over dx is the derivative of y with respect to x. So if I have dy over du, that would be the derivative of y with respect to u, and then du over dx is the derivative of u with respect to x. So if I kind of put all these together, I'm going to get the derivative of y with respect to x. And we're going to do this problem from the first slide both ways. You can kind of see and make your own assumption of how you want to do these problems. So I'm going to do this the first way. So remember that this is the same thing as saying x squared plus 1 to the 1/2. So the first thing I'm going to do is determine what's my outer function and what's my inner function. So the outer function is whatever you have on the outside. So in this case, my outer function is the square root of something, right? The square root is what's the farthest thing on the outside. So I can rewrite that as like something to the 1/2. My inner function is going to be literally what's inside. So my inner function is going to be x squared plus 1. So if we think about this in terms of a composition, this is like my f, the outer, and the inner is my g. So what I'm really doing here is I'm finding the derivative of f of g of x, right? So this is really f prime of x that we're trying to find, but it's really this composition. So to do this, we're going to take, I'll just follow this up here. We're going to do the derivative of the outer function evaluated at the inner function times the derivative of the inner function. So if I was taking the derivative of this, I would have the derivative of my outer, which is like something to the 1/2. So the derivative of that would be 1/2 something to the negative 1/2. And that something is the inner function of x squared plus 1. So this x squared plus 1, that's my inner, is going to go inside. And then I'm going to multiply by the derivative of that inner function. So I'm just going to write it like this, by the derivative of x squared plus 1. So really what I have is 1/2 x squared plus 1 to the negative 1/2 times 2x. And then we can multiply this together. The 1/2 times the 2, that's going to just give us x, and then I'm going to bring the radical to the bottom and make it positive since it was a negative on the top. So I have the square root of x squared plus 1. And here is my derivative. Okay, so I'm going to do the same exact problem the other way so you can see how to do it. Some people think the other way is easier or the first way is easier. It really is your preference. So if I was doing it the second way, I need to identify what u is going to be. So u in this case is always going to be the inner function. So u would be our x squared plus 1. And then our y is going to be the outer function at u. So it's going to be the square root of u. So we're plugging in u. And then we're going to write dy over dx equals dy over du times du over dx. Right? And we can see that mathematically the du's would cancel out and we get dy over dx. That's why this is the same thing. So if I want to find dy over dx, I'm going to take the derivative of y with respect to u. So I'm going to look here at my y, and I'm going to take the derivative with respect to u. So meaning u is going to be in my answer. So it's the square root of u, so that's really like u to the 1/2. So I'm going to have 1/2 u to the negative 1/2. And then I'm going to multiply that by the derivative of u with respect to x. So here's u, x squared plus 1. The derivative of that with respect to x would be 2x. Okay, so again, I'm going to multiply the 1/2 times the 2x, so that's x. And then on the bottom, I have the square root of u. But I can't have u in my answer because I'm trying to find dy over dx, the derivative of y with respect to x. So I want to substitute back in my u. So u is x squared plus 1. So I'm really going to have x over the square root of x squared plus 1. Okay, so we're going to do more with this idea of u a little bit later on. So if it's something that doesn't really make sense right now and you'd rather do it the first way, by all means do it the first way. If you want to do the second way, do it the second way. Going forward, I'm going to use the top method. But again, if you feel more comfortable using the u's, please go ahead and do that. Okay, so here we want to find the derivative of sine of x squared. So first thing we want to do is identify what the outer function is. So outer function is going to be sine of something. The inner function is going to be x squared. So if I want to find y prime, it's going to be the derivative of the outer. So the derivative of sine would be cosine. And then it's evaluated at the inner function. So the inner function is x squared. And then we're going to multiply it by the derivative of the inner. So again, I'm just going to write it like this so we see where it's coming from. Okay, so it's the derivative of the inner. So this is going to be cosine x squared times 2x. So I'm just going to flip-flop my order just because I like to have it like that. So 2x cosine x squared. Okay, in the second example, they look similar, but the difference here is that it's sine squared x. So we can rewrite sine squared x as sine x quantity squared, like that. So when I'm trying to identify my outer function, outer in this case will be something squared, right? And then your inner function is what's inside. That will be your sine x. So when I go to find my derivative, y prime, it's going to be the derivative of the outer function. So the outer function is something squared. So we're going to use the power rule. So it's going to be 2 times something to the first power. That something is going to be the inner function. So we're going to plug in the sine x. And then we multiply it by the derivative of the inner function, which is sine x. So the derivative of the sine x is going to be cosine x. So I'm just going to tack that right on. And here is our derivative. Okay, so we're going to find f prime of x if f of x is equal to square root of x cubed minus x plus 1. Okay, so again, first thing we do is identify the outer. So here the outer function is going to be the square root of something. My inner function is going to be x cubed minus x plus 1. When I take my derivative, I'm going to do the derivative of the outer. So that's going to be 1/2 something to the negative 1/2. That something is going to be our inner function. So I'm going to plug that in, x cubed minus x plus 1. And then I'm going to multiply by the derivative of the inner function. So I can just use the power rule for that. So I'm going to have here 1/2. I'm just going to keep this the same. X cubed minus x plus 1 to the negative 1/2 times 3x squared minus 1. Okay, and then I'm just going to clean it up a little bit. If I multiply this, I'm going to keep the 3x squared and minus 1 on the top. The bottom, I'm going to have a 2, and then I'm going to bring down my radical and make it positive here. And then here is my derivative. Okay, now we want to write an equation of the tangent line to the curve y equals the square root of 10 minus 3x at the point 2, 4. So we're going to first have to find the derivative, because when we're finding the equation of the tangent line, we need to find the derivative at the point in order for us to find the slope. So I'm going to do y prime. So here, again, I'm just going to make a little thing up here. My outer function is going to be the square root. My inner function is going to be 10 minus 3x. So I'm going to take the derivative of the outer function, so 1/2 something to the negative 1/2. That something is going to be my inner function, so 10 minus 3x. And then we're going to multiply it by the derivative of the inner function, so derivative of 10 minus 3x. So we get y prime equals 1/2 10 minus 3x to the negative 1/2 times negative 3. So if I smush this together, I get y prime is equal to negative 3 over 2 square root of 10 minus 3x. And now I want to find this at the point 2, 4. So this is my derivative as a function. I want to find the derivative at a point. So I'm going to plug in 2 for x. So I'm going to do y prime of 2. So I have negative 3 over 2 square root of 10 minus 3 times 2, which is 6. So negative 3 over 2 square root 4. So I end up with negative 3 over 4. And that is my slope. Okay, that's my derivative at the point, which is the same thing as my slope. Once I have my slope and I know the point, I'm going to create my equation of the tangent line. So I'm going to do y minus my y value for the point, which is 4, equals my slope, which is negative 3/4, x minus the x value of 2. So you can leave it like that. If you want to solve it, we're going to get negative 3/4 x, and then here we get 3 halves, and then we're going to add 4, so 8, so 11 halves. There's our equation. Okay, now we want to differentiate e to the sine x. So again, let's identify our outer function. So our outer function is going to be e to something. Our inner function is going to be sine x. So y prime is going to be the derivative of the outer. So that's e something, right? The derivative of e to the something is e to the something. And then we're going to multiply, so that something is going to be sine x. And then we'll plug that in. And then we're going to multiply it by the derivative of the inner, so derivative of sine x. So we're going to get e to the sine x. The derivative of sine is going to be cosine x. We can use the power rule combined with the chain rule. So when we're doing the chain rule, we have the outer function and the inner function, which in this case we still do. For the power rule combined with it, we can think of it like we did before, or we can kind of look at something like this or this. Basically, we're doing your power rule. So you're going to take your exponent, multiply it down in front, and subtract 1. But then you have to make sure that you multiply by the derivative of what is inside. So again, if you want to think about your outer function and your inner function, the outer function is something to the fourth. The inner function is this 2x cubed minus 1. If I were to do the power rule on this, the 4 is going to come down. So y prime is going to be 4 times 2x cubed minus 1 to the third. But because what's inside has a derivative, I have to multiply by the derivative of what's inside. So the derivative of 2x cubed minus 1. So I end up with 4 times 2x cubed minus 1 cubed times 6x squared. And then I'm going to actually just multiply those together. So y prime is equal to 24x squared 2x cubed minus 1 to the third. For this last problem, we're going to look at another equation of the tangent line. So here we have a function y equals x squared plus 1 to the third at the point 1, 8. So again, first thing we need to do is we need to find the derivative. So we're going to do y prime equals. I'm going to use the power rule with the chain rule. So I'm going to bring the 3 down, and then I have x squared plus 1 to the second power times the derivative of what's inside, so times 2x. So I end up with y prime is equal to 6x, x squared plus 1 squared. And now I'm going to find this at the point 1, 8. So I'm going to do y prime of 1 to find the slope at 1. So I'm going to plug that in. I'm going to get 6, and then I'm going to get 2 squared. So this is going to give me 6 times 4, which is 24. And that is going to be my slope. And then I'm going to do my equation of the tangent line by using point slope form. So y minus my y value of 8 equals my slope of 24 times x minus my x value of 1. So then I'm going to have y equals, and I'm going to have 24x, and then I have negative 24 plus 8, so negative 16. And that will be my equation of the tangent line.